are going to see the vector differential calculus. So before to start this chapter, vector differential calculus, we should know some basic part. What is that? Dot product, cross product, magnitude. Then if in the form of I, J, K means what? So that things we should know. So let's start here vector differential calculus. You must remember here before to start this vector differential calculus, that is the dot product, means A and B are two vectors. Note that here vectors denoted by like this A bar. So you can see here the bar and here also bar. So dot product of two vectors is nothing but AB cos theta, where A is a magnitude. Normally magnitude of any vector we are denoting by this or simply A. So AB cos theta. What is this theta? So theta is the angle between two vectors A and B. Also you have to remember cross product, means A and B are two vectors, then A cross B. Note that it is denoted by this cross, like this cross. So A cross B equal to AB sin theta n cap. Note that here A is a magnitude of A, vector A, and B is a magnitude of vector B, that denoted by like this sin theta n cap. What is this n cap? It is a unit vector. Means unit vector means magnitude of this vector is 1. So it is a unit vector perpendicular to both vectors A and B. Okay, or you can say here n cap is a unit vector normal. Normal means which is nothing but a perpendicular to the plane. So here normal to the plane of A and B. Also you remember here I, J, K, especially these I, J, K are the unit vectors along x direction, along y direction and along z direction respectively. Also you remember A dot A. So what is the A dot A? By this definition I can write A dot A equal to A into A cos theta. Theta is the angle between them. It means that what is the angle between that vector itself? It is a 0. What is the cos 0? It is 1. So I am getting only A into A, and A into A is A square. That is why you remember A dot A equal to A square. You also remember if vectors A and B in the form of I, J, K, then A dot B equal to A1 B1 plus A2 B2 plus A3 B3. Means what is this dot product? It is just the multiplication of coefficient of I plus multiplication of coefficients of J plus coefficients of K. So also you remember A cross B equal to determinant of I, J, K, A1, A2, A3, B1, B2, B3. You can see here A1, A2, A3 are the coefficients of I, J, K of the first vector. Similarly, B1, B2, B3 are the coefficients of I, J, K of second vector. And you also remember here the magnitude of that any vector A is nothing but under root of A1 square plus A2 square plus A3 square. It means that here A1, A2, A3 are the coefficients of I, J, K. So here one can consider, suppose A is one vector and here 2I plus 2J plus 3K. So what is the magnitude of it? I can write here magnitude is under root of, what is the 2 square? It is the 4 plus square of this, it is the 4 plus square of this, it is a 9. Under root of 17, that is the magnitude of this vector A. Also you just observe here, if A equal to I plus 2J plus 3K supposed to be there, and B is another vector, that is a 4I plus J minus 2K. Then what is the A dot B here? That is nothing but what is the coefficient of I here? 1 into 4, here I am getting 4 plus 2 and minus 6. You can see 3 into minus 2. That is minus 6. So that is equal to A dot B equal to 0. Similarly, you can find here this A cross B also of this one. So also you remember that if A is any vector, then the unit vector along the vector A is denoted by a cap. How that? A cap. This is a vector A, and a unit vector along this vector A denoted by a cap, and it is given by vector A upon mod of vector A. We know that any vector A, it means that only magnitude and only direction. So only direction means it is a unit vector along that vector A. That is why A cap equal to A upon mod of A. So meaning is what? A upon simply A means only magnitude of that A. Also you remember very important formula here. Throughout this chapter when we will get there, 2 cross. For example, here 3 vectors and 2 cross. So A cross B cross C. So here A, B, C are the vectors. Then that is equal to A dot C into B minus A dot B into C. So it is known as vector triple product. So these 7 things we have to remember without fail. Also you consider the gradient of scalar point function. So what is that one? If a scalar function phi is continuous and differentiable, then the gradient of scalar point function phi is defined as grad phi, that is equal to dabba phi by dabba xi plus dabba phi by dabba yj plus dabba phi by dabba zk. Now just introduce here a vector operator del. This is a del, and it is defined as del equal to dabba by dabba xi plus dabba by dabba yj plus dabba by dabba zk. So if we observe this one, the grad phi I can write as del phi, because del is what? This is the del. If we multiply this del by phi, so this phi multiplication. So I am getting here dabba phi by dabba xi plus dabba phi by dabba yj plus dabba phi by dabba zk. And that is why I can write here grad phi means what? It is a del phi. Note that it is a simple product, ordinary product, because phi is a scalar here. And we know when there are two vectors A and B, then there will be either dot product or cross product. But if any scalar is there, even though here it is vector, then there will be a in between that simple product. In this unit vector differential calculus, be careful about this dot and cross. For example, here A and B, so there should be dot or cross like this. So such type of basic things you have to remember throughout the chapter. Now the one application of gradient of scalar point function is nothing but the directional derivative. So what is the directional derivative? The rate of change of phi at any point supposed to be P along given direction is called directional derivative of phi at P. And that is why the definition, by this definition I can write the directional derivative of scalar point function phi equal to constant at any point P in the direction of given vector A is given by del phi dot A cap. So what is A cap? A cap is a unit vector along the vector A, and that is nothing but A cap equal to A upon mod of vector A. So note that this del phi at point, particular point P, x, y, j. So don't forget this definition of directional derivative. You must remember these things also. The directional derivative of scalar point function phi equal to C at point P, that is the directional derivative along the direction of vector A, is given by del phi dot A cap. A cap is a unit vector, and that we can find by vector A upon mod of that vector. And second thing is grad V is a vector normal to the surface V equal to constant. Means if any surface V equal to constant, then we can find a vector normal to that surface is nothing but del V. And that is why if phi is a one surface, then what is the vector normal to this surface is del phi and has magnitude equal to the rate of change of V along this normal. Also you remember this del V gives maximum rate of change of V, and magnitude of this maximum is mod of del V. So for the MCQs, you must go through all these notes. In the exam, you can find the examples on the directional derivatives like that. Find the directional derivative of phi at point P, supposed to be any point, along the direction. So that direction may change. So that direction along the normal, along the tangent, along the line, along the points, like that, you can get it. And that is why you should know how to find this direction vector. Okay? And that is why you have to remember the next note. What is that? A vector along the line x minus a by l equal to y minus b by m equal to z minus c by n is li plus mj plus nk. So what is this l, m, n? That is li plus mj plus nk. Note that here should be x minus a, y minus b, z minus c. If suppose there will be b minus y, so first you take a minus common and you write y minus b, and that minus will be for denominator, and then you decide this value. Similarly, that L and N. So I can get here the vector along such type of line. Second, a vector along a line from point P towards Q is nothing but I can denote it as like this PQ. And it is nothing but Q minus P. Means what? X2 minus X1 I plus y2 minus y1j plus z2 minus z1k. And that is why I can write a vector along the line PQ is x2 minus x1i plus y2 minus y1j plus z2 minus z1k. Also, you remember very important part that when we want to find a vector normal to surface V equal to constant, and that is nothing but del of V, means del V. A vector tangent to the curve, any curve, that is x, y, z in terms of t here, is dr by dt here, vector r. So what is vector r? It is xi plus yj plus zk. So I am getting here in terms, means here dr by dt. It is a tangent vector along the curve, this x, y, z here given in the form of t. So now consider one MCQ on this vector differential calculus. Is the tangent vector to the curve r equal to this given at t equal to 0 is given by. Before to that, we should know what is the tangent vector. Means tangent vector to the curve, that we know it is a dr by dt. Okay. So what is the tangent vector? So if I am going to denote it is as a t bar, then it is equal to dr by dt. If I am going to denote it is as a t bar, so it is a tangent vector dr by dt. And what is the r? R is given here. Here e raised to t I plus e raised to t sin tj plus e raised to t k. So what is the dr by dt? So I am getting here dr by dt means differentiation of r with respect to t is e raised to t into I plus. So u into v rule here with respect to t. So I am getting here e raised to t cos t, first constant derivative of second plus second constant derivative of first into j plus e raised to t k, because derivative of e raised to t is e raised to d. Now I want t equal to 0, and that is why I am getting here t equal to e raised to 0 is what? It is 1. So I am getting 1 into I, means simply I, plus what is cos 0? It is 1, and sin 0, 0. So that is why I am getting here 0, and here 1, e raised to 0 is 1. 1 plus 0, it is 1. So again it is j, plus here also e raised to 0, it is 1. So only k. So I plus j plus k. So which is the correct option here? D option is the correct one. Now next MCQ is what? The angle between tangent to the curve, this curve, at t equal to 0 and the z axis is. So first of all, you remember, if a and b are two vectors, then what is a dot b? It is a ab cos theta, where theta is the angle between these two vectors. And that is why by using this formula, I can find cos theta equal to a dot b upon ab, where a and b are the magnitude of vector a and vector b. So by using this, I want to find these two vectors. So first vector is what? Between tangent to the curve. So what is the tangent of this r? It is dr by dt, and it is given, but at t equal to 0. So dr by dt, that is your tangent vector. So I will denote it by t bar. The t equal to 0. So what is e raised to 0? It is 1. Sin 0 is 0. E raised to 0 is 1. Cos 0 is 1. So 0 plus 1 I am getting. So I am getting I only. Now e raised to t, it is g. E raised to t means e raised to 0. I am getting here 1. Cos 0 is 1. Sin 0 is 0. So again here plus j plus e raised to 0, that is plus 2. Okay, so this is one vector, that is tangent to the curve, angle between tangent to the curve and the z axis. So what is the z axis? So vector along the z axis is nothing but k bar, right? And therefore I want to find angle between this. So t bar dot k bar equal to magnitude of this t bar, magnitude of this k bar into cos theta. So therefore what I am getting here? Cos theta equal to t bar dot k bar upon magnitude of this t bar and magnitude of this k bar. So what is the t here? It is nothing but I plus j plus k dot k bar whole divided by what is the magnitude? Magnitude of any vector we know the under root of square of coefficient of I, square of coefficient of j plus square of coefficient of k. And what about here this k? Only k, it means that it is a 0i plus 0j plus k, and that is why magnitude of this is 0 square under root of 0 square plus 0 square plus 1 square. So I am getting like this. Now dot product of this, you know what is the a dot b? It is the a1 b1 plus a2 b2 plus a3 b3, means here coefficient of I. So what is the coefficient of I in between this? So that is why I am getting here 0 plus 1 upon under root of this 3. So I am getting 1 by root 3. It is a cos theta. So what is the angle theta? It is a cos inverse of 1 by root 3. By calculator you can find this value, but here the option MCQ. So let's check here option is there or not. So what is that? Cos inverse 1 by root 3. So here A option is the correct one. Now the next MCQ. So this MCQ is, if for the curve r equal to, means vector r equal to t cube plus 2i plus 4t minus 5j plus 2t square minus 6tk, and dr by dt is given here, right? 3t square I plus 4j plus 4t minus 6k. Then the angle between tangents to the curve at t equal to 0 and t equal to 2. So here tangent is given. So what is the tangent here? It is a dr by dt. It is given. So what is that one? It is a 3t square I plus 4j plus 4t minus 6k. But here we want to find angle between tangents, means two tangents when t equal to 0 and t equal to 2. So if I am taking here t equal to 0 and that tangent is supposed to be t1. So what is it? When t equal to 0, I am getting here 0i, 4j, and t equal to 0 means minus 6k. And at t equal to 2, so I am getting second vector, as I will denote it as t2. So what is it? T equal to 2. So 2 here. So it will be a 4 into 3. It is a 12i plus 4j. And if we put 2 here, so it is a 8 minus 6. So it is a 2k. And therefore I want to find angle between them. And that is a t1 dot t2. That is equal to mod of t1 mod of t2, means magnitude of t1 t2 into cos theta. Therefore I am getting here cos theta equal to t1 dot t2 upon mod of t1 mod of t2, means magnitude of t1 t2. So therefore what is the cos theta? Cos theta equal to t1. It is a 0i plus 4j minus 6k dot t2. It is a 12i plus 4j plus 2k whole divided by magnitude. Magnitude is what? Under root of. So I am using here the formula. For your reference, you can use this one. In theory part, we already see. And that is why it is a 0 plus 4 square, it is a 16 plus minus 6 square, it is a 36. And here under root of, because here what is the magnitude? You can see here. And with that, what is the square of this 12? It is the 144 plus square of this, it is 16 plus square of this, it is a 4. So what I am getting here? So what is A dot B? A dot B equal to A1 B1 plus A2 B2 plus A3 B3. And that is why I am getting here 0 plus 4 into 4, it is 16 minus, it is a 12. Note that here I am taking A1 B1 plus A2 B2 plus A3 B3. So whole divided by, what is this? Under root of 16 plus 36, root of 52, and a root of, what about this one? It is 164. So that is equal to 4 upon under root of 52 into under root of 164. So it is a cos theta. So what about theta? If you want to find a theta here, that is equal to cos inverse 4 upon root 52 into root 164. By calci you can find value of this, but see the option here. Okay, so multiplication, both multiplication. So what is the multiplication of 52 into 164 that you find? So here I am getting that is equal to cos inverse 4 upon under root of 8528. So 4 upon 8528. So here C option is the correct one. So you also remember there the theoretical part. maybe the definition of directional derivative, maybe the definition of curve, divergent, gradient. You will find MCQs on that. So here is one theoretical question: maximum directional derivative of scalar point function phi in the direction that we already consider as a node, that is the maximum directional derivative along the direction del phi. If we consider that function is phi, direction del phi, it will be a maximum. So what is del phi? And we know del phi is a normal vector to the direction phi, and we know del phi is a normal to the surface phi. So normal vector. What is that? Maximum directional derivative of scalar point function phi in the direction of normal vector. Actually, it is del phi. Now consider the MCQ. Unit vector in the direction of normal to the surface at 1, 1, 1. So if I am denoting this phi as a surface, it is nothing but x square plus y square plus z square equal to 3, or one can write here minus 3 equal to 0. Normally when we are taking a surface, always I will consider phi equal to 0 or phi equal to constant. So here first you find the directional, means a vector direction of normal to the surface, that we know it is a del phi. So what is the del? Del is dabba by dabba xi plus dabba by dabba yj plus dabba by dabba zk. And what is the phi? It is a x square plus y square plus z square minus 3. So you take here, it is a simple product, and that is why first into all, second into all, third into all. And that is why one can write here dabba by dabba x of all means what? X square plus y square plus z square minus 3 I. Similarly, dabba by dabba y of all and dabba by dabba z of all. And that is why you take a dabba by dabba, means differentiation of this with respect to x, differentiation of this with respect to y, differentiation of this with respect to z. So I am getting here 2xi plus 2yj plus 2zk. So it is a normal vector to the surface phi. But we want to find unit vector. Which point? 1, 1, 1. So that is why at point 1, 1, 1. So what is the meaning of this one? It means that you put x equal to 1, y equal to 1 and z equal to 1. I am getting here 2i plus 2j plus 2k. You can take here 2 common. So here only I plus j plus k. If I am denoting this as a n, means normal vector, and unit vector means n cap. What is n cap? Unit vector along the normal is nothing but n bar upon mod of n bar. So what is n bar? It is a 2 in bracket I plus j plus k whole divided by under root of square of this. It will be 4 in bracket square of this is 1 plus 1 plus 1. Okay. So normally if we are taking common, so in this case I am taking always here 2 outside. So without that also you can take. So what is the meaning of this? If suppose I am taking this one, so here it will be a 2i plus 2j plus 2k whole divided by under root of, it will be a 4 plus 4 plus 4. So 4 common, and in bracket I am getting 1, 1, 1. So square of this, square of this, square of this. So in the next examples you can take it directly to outside, and here I plus j plus k. Here also that 2 outside, and here only under root of 1 plus 1 plus 1. So this 2 to cancel. So what is the unit vector along normal? It is a I plus j plus k whole divided by under root of 3, or one can take 1 by root 3 in bracket I plus j plus k. So is that, so which is the correct option here? Here D option is the correct option. So consider one example on the directional derivative, that is find the directional derivative of phi equal to x square yz plus 4xz square at the point 1 minus 2 minus 1 in the direction of vector 2i minus j minus 2k. So how to find directional derivative? So solution is, so in step number 1 you declare the formula. What we know, directional derivative of phi equal to c at point P along the direction vector A is equal to del phi at point P dot A cap. So this is first formula. So this is equation number 1. So what we want to find? We want to find del phi, we want to find A cap. So what is the phi here? So given thing, you declare the given thing here. So given phi, directional derivative of what? Which surface? That you declare as a phi. So given phi equal to x square yz plus 4xz square, at which point? So that point P you declare, that is a 1 minus 2 minus 1. So this is equation number 2. So now we want to find del phi at point P. So that is your step number 2. What is the del phi? Del phi equal to, del means what? Dabba by dabba xi plus dabba by dabba yj plus dabba by dabba zk. Phi. What is the phi here? Phi is given. This is your phi. So phi equal to x square yz plus 4xz square. So dabba by dabba x of all this phi plus dabba by dabba y of all this phi into j plus dabba by dabba z of all this phi. So I can write here dabba by dabba x of this one. One can use direct step also, plus dabba by dabba y of phi. Phi means here x square yz plus 4xz square j plus dabba by dabba z of x square yz plus 4xz square into k. So you take the differentiation of this with respect to x, differentiation of this with respect to y, differentiation of this with respect to z partially. It means that when we are taking the differentiation with respect to x, that time y and z constant. And that is why I am getting here. What is the derivative of this with respect to x? It is a 2xyz plus 4z square. So here derivative of this x square is 2x, yz constant, and here derivative of x is 1, 4z square constant, plus dabba by dabba y of this, means differentiate this with respect to y. So this not contains y, so differentiation of this with respect to y is 0. What about the first term? So it will be x square z j, and similarly differentiation of this with respect to z, it is x square y plus 8xz. Why? Because here x square y constant derivative of z is 1, 4x constant derivative of this is 2z k bar. So this is a del phi. What we want to find? We want to find del phi at point P. So here point P is 1 minus 2 minus 1. So at point P, 1 minus 2 minus 1. So what is the meaning of this at point P? It means that you have to put this P point in del phi. Means here value of x is 1, value of y is minus 2, and value of z is minus 1. So I am getting here, see there, 2x y z plus 4 z square. It is a 4 plus 4, that is 8. So I am getting here 8i. What about this one? Here again x square means 1 square and z means minus 1. So I am getting here minus 1. And what about this? If we put x is 1, y is minus 2 plus 8xz, and that is nothing but minus 2 minus 8, it is a minus 10. So I am getting here minus 10k. So therefore we have the first part now, del phi at point P equal to 8i minus j minus 10k. So this is equation number now 3. So in this case we have this part. Now we want to find a cap. A cap is what? Along which direction we want to find directional derivative. That is your a bar. And by using this a bar I can find a cap. So in the given example, in the direction of vector 2i minus j minus 2k. So this is your vector a bar. So step number 3 now. Here the direction along vector a equal to 2i minus j minus 2k. 2i minus j minus 2k. And we know how to find a cap. A cap is what?
it is a unit vector along the vector A, and A cap equal to vector A upon magnitude of vector A, and that is equal to 2I minus j minus 2k. And what is the magnitude of it? It is the under root of coefficient of I square plus coefficient of j square plus coefficient of k square, and that is equal to, I am getting here, 2I minus j minus 2k whole divided by under root of 4 plus 1 plus 4. So therefore A cap equal to, so what is this one? This is a 4 plus 1 plus 4 means 9. So under root of 9 is 3. So under root of 9 is 3. So I am getting 1 by 3 in bracket 2I minus j minus 2k. So this is A cap. This is equation number 4. So if we see the formula, that is, we want del phi and A cap. So both value we have. Now substitute these values in equation 1. So step number 4. Now actual directional derivative. So substitute values from equation 3 and 4 in equation 1. So what we get? We get directional derivative of phi at A equal to del phi at point P dot A cap. So both value we have. So from equation 3, del phi is what? 8I minus j minus 10k. So that value you put here, it is a 8I minus j minus 10k dot, what is the A cap? It is a 1 by 3 2I minus j minus 2k. So this is your A cap. As we know, the dot product A dot B equal to A1 B1 plus A2 B2 plus A3 B3. It means that coefficients of I, J, K, and here B1, B2, B3 are coefficients of I, J, K of vector B. So using this, I can write here that is equal to 1 by 3 in bracket 8 into 2 plus minus 1 into minus 1 plus minus 10 into minus 2. So what is this value? So in short, I can write directional derivative of phi equal to 1 by 3, and this value is 16 plus 1 plus 20. So what is the final answer? Directional derivative of phi equal to 37 by 3. So this is your final answer. Now consider the another example. Find the directional derivative of phi equal to x square minus y square plus 2z square at the point P 1, 2, 3 in the direction of line PQ, where Q is the point 504. So how to solve this one? So let's consider the solution of it. Step number 1. What we want to find? Directional derivative. So what is the formula for that? That we know directional derivative of phi equal to C at point P along the vector A is equal to del phi at point P dot A cap. So this is equation number 1. So we want to find del phi as well as A cap. So how? Let's see. So now what is the given thing? So you declare the given thing. Here given phi. Phi means what? Directional derivative of what? That is your phi. So we want to find directional derivative of phi equal to x square minus y square plus 2z square at point P 1, 2, 3. So this is your equation number 2. So now find del phi. How? So consider step number 2 here. To find del phi equal to, del means what? Dabba by dabba xi plus dabba by dabba yj plus dabba by dabba zk of phi. What is the phi here? Phi equal to x square minus y square plus 2z square. So you solve this one. It means that first dabba by dabba x of phi means x square minus y square plus 2z square. This I plus dabba by dabba y of x square minus y square plus 2z square j plus dabba by dabba z of x square minus y square plus 2z square k. And that is why we will get here. So derivative of this with respect to x, derivative of this with respect to y, and derivative of this with respect to z. So it gives del phi equal to derivative with respect to x, y and z constant, because it is a partial derivative. So 2xi plus dabba by dabba y means partial derivative of this with respect to y. So we get here minus 2yj plus dabba by dabba z of this partial derivative of this with respect to z. Here x and y constant. So that is equal to 4z k bar. So at point P, we want to find del phi. So what is that P point? So P point 1, 2, 3. So del phi at point P, it means that we have to put x equal to 1, y equal to 2, z equal to 3. So 2x, it means that 2 into 1, 2y, minus 2y means 2 into y means 2 into 2, it is a 4j, and 4z means 12k. This is your del phi. It is equation number 3. So now we have this one. So what about a cap? A cap is a directional derivative of which direction? That vector is a bar. So here a bar in the direction of line PQ. So step number 3, here vector A equal to along the direction PQ. So PQ is one vector supposed to be, where P is 1, 2, 3 and Q is 5, 0, 4. As we know, a vector along the line from point P to Q is x2 minus x1i plus y2 minus y1j plus z2 minus z1k. So this is for your reference. So therefore, here vector A equal to PQ. It means that Q minus P. How? I can write here, it is a 5 minus 1i, 5 minus x2 minus x1 plus 0 minus 2j plus 4 minus 3k. 0 minus 2j, 4 minus 3k. So therefore, vector A equal to 4i minus 2j plus k. So therefore, we want to find A cap, and which is equal to A bar upon mod of A. It means that magnitude of A, and that is a 4i minus 2j plus k upon what is the magnitude of A. We know if A is a vector, then magnitude of A is under root of A1 square plus A2 square plus A3 square, and therefore I am getting under root of 4 square plus minus 2 square plus 1 square, and that is equal to 4i minus 2j plus k whole divided by under root of 16 plus 4 plus 1 means it is a 21. So A cap equal to 1 by root 21 into 4i minus 2j plus k. So now we have both value, that is A cap as well as del phi at point P, and therefore we can find directional derivative of phi. So now final step, it is step number 4. Substitute values from equations 3 and 4. In equation 1, we get directional derivative of phi equal to del phi at point P dot A cap, and that is equal to del phi at point P 2i minus 4j plus 12k, 2i minus 4j plus 12k dot A cap. What is it? It is 1 by root 21, this value, in bracket 4i minus 2j plus k. As we know, A dot B equal to A1 B1 plus A2 B2 plus A3 B3. So by using this directional derivative of phi, that is equal to 1 by root 21 as it is, and here I am getting 2 into 4 plus minus 4 into minus 2 plus 12 into 1 means multiplication of coefficients of I, J, K. So what is this value? By calculator you can find this value. It is 8, it is plus 8 and it is a 12 means 28. So 28 by root 21. It is a directional derivative of phi, which is your final answer.